And since I accidentally clicked my mouse there, I'm just going to continue where we were and start right away with example number 1, in which we have a game of curling, and a collision occurs between two stones that have equal mass. The object stone is initially at rest, and after the collision, the stone that is thrown has a speed of 0.56 meters per second in the same direction, theta, and the object stone acquires a velocity of Vf2, which is equal to 0.42 meters per second at an angle of phi, 30 degrees from the original direction. We shall determine the initial velocity of the thrown stone. So we're thinking about, in this case, we have m1, which was initially thrown at some velocity vi1, and it strikes this other stone of equal mass m2. And because of this glancing collision, they both travel now in two different directions. And similar to before, if we can analyze these, our first mass travels, our first stone at an angle of theta, our second one at an angle of phi. And we will see that if this is our Vf1 in which our first stone is traveling, we can calculate the momentum similar to what we have done many times before. This would be our momentum. Pf1 in the y direction would be Pf1 sine theta. Our second stone, if this is Vf2, we would have Pf2 in the y direction being as Pf2 sine phi. And similar to our x direction, we would have Pf1x as being Pf1 cosine theta, and Pf2x, it's getting rather crowded here, would be Pf2 cosine of phi. And all of these can be used if we analyze these in the x and y components, which we shall do right now. Due to the direction of travel and the conservation of momentum, our y direction, the total momentum before and after is 0. And this is due to the fact that our Pti in the y direction will be equal to our momentum, final momentum in the y direction, and that will be 0. So that tells us that Ptfy, our final momentum in the y direction, will be mvf1 sine theta minus mvf2 sine phi, and all of that is equal to 0. Rearranging this a little bit, what we end up getting is that mvf1 sine theta is equal to mvf2 sine phi. And if we were to solve for theta in this case, we would get that it would be equal to sine inverse of Vf2 sine phi all over Vf1. And you'll notice that my m's have dropped out because we have the same mass both on both sides of the equal sign. And a simple substitution now will help us solve for what that angle was. So sine inverse, and we have 0.42 sine 30 degrees all over 0.56 meters per second. And that calculation tells us that after the collision, the first rock, the rock that was thrown, was traveling at an angle of 22 degrees. And we solve this because it is useful for us when we analyze the x components. That is the reason we just solved for our angle theta. When I look at my x components, very similar to the conservation of momentum, our total initial momentum in the x direction will be equal to our total final momentum in the x direction. So that tells us that m1 vi1x plus m2 vi2x will be equal to m1 vf1x plus m2 vf2x. And since all the masses are the same, they cancel out. And also we are given that mass 2, the second stone, the object stone, was initially at rest. So to help us calculate Vix is rather easy now. We have Vf1x plus Vf2x. So calculating that now, we have Vf1 cos theta plus Vf2 cos phi. So we get 0.56 meters per second cos of 22 degrees plus 0.42 meters per second cos 30 degrees. And calculating that, we get that the initial speed or velocity of the stone was 0.88 meters per second, and that will be in the right direction. And I'm hoping that you were able to follow, for the most part, what just happened in this question. In example number 2, we have a case where two cross-country skiers, collide at a right angle. And we have both skiers. One has a mass of 84 kilograms, and the other a mass of 72 kilograms. One was traveling east, while the other was traveling north. We're going to calculate the final velocities of the two skiers, and we should note that these two skiers, when they collide, their skis lock up, and so therefore they move together at the end. And we should remember that total final momentum will be equal to our total initial momentum, and our initial momentum is made up of P1 plus P2 coming from both skiers. And if we look at the first skier, which was 84 kilograms and traveling east, we can calculate that momentum P1, which is M1 V1, and that will be 84 multiplied with 5.1 because they both had the same speed, and that will be 428 kilogram meters per second, and that skier was traveling east. The second momentum, M2 VI2, that will be 72 multiplied by 5.1, which we calculate to be 367 kilogram meters per second, and that one is in the north direction for skier 2. And these two collide at the right angle, so we can actually draw this as a right triangle. We have the one skier in the east direction of 428 kilogram meters per second. We have the other one that was traveling at 367 kilogram meters per second in the north direction. And we can calculate what our total momentum was quite easily due to the fact they're at a right angled triangle. So PT from Pythagorean theorem will be the square root of 367 squared plus 428 squared, and that gives us 564 kilogram meters per second. We can determine what angle the skiers are traveling at together at the end too. Theta tan inverse 367 all over 428. We can determine what that value is. Theta would be 41 degrees. And because these two stick together, this is a perfect inelastic collision. So, PF, our final momentum, is equal to m1 plus m2 multiplied by Vf. And that's going to be the final velocities of our skiers. So therefore, Vf is equal to that final momentum all over m1 plus m2. Therefore, 564 over 84 plus 72. So our final velocity is 3.6 meters per second east, 41 degrees north. And that is the last lesson for Chapter 5, and the test will be released in a couple of days for you to complete.